I welcome you all to this presentation on chemistry, where we have been given this question. So the information reads: limestone is an impure form of calcium carbonate. This is calcium carbonate. The percentage of calcium carbonate in limestone is investigated as follows. 10.2 gram of limestone is added to excess 300 centimeter cube of 1.00 mole per decimeter cube of hydrochloric acid. Okay, the whole calcium carbonate in limestone reacted as the only reactant in the limestone according to the equation. So this is the equation that we have been given, where there is calcium carbonate plus hydrochloric acid, and then you have calcium chloride plus H2O plus carbon dioxide. Then the remaining acid requires just 4.0 gram of sodium hydroxide for complete neutralization. Then again we have this equation where we have sodium hydroxide plus hydrochloric acid. You get sodium chloride plus water, which is a neutralization equation. Question is determine the number of moles of hydrochloric that had earlier reacted with calcium carbonate. 2. Hence, calculate the percentage purity of calcium carbonate in limestone. So, for us to answer these questions, first thing we need to go back and see what we have been given. Then the first one is determine the number of moles of hydrochloric acid that had earlier reacted with calcium carbonate. So in this equation, what we want is the number of moles that was earlier reacted with this calcium carbonate, and the number of moles are for hydrochloric acid, because here again we are told that the remaining acid requires just 4.0 gram of sodium hydroxide for completing neutralization. Here we have been given this equation. So now for us to answer, first thing we can find the moles of hydrochloric acid given this information, because in this information we are told that 10.2 gram of limestone is added to excess 300 centimeter cube of 1.00 mole per decimeter cube of hydrochloric acid. So these figures are for hydrochloric acid. So this is the volume for hydrochloric acid, and this is the concentration for hydrochloric acid. So what we do here, we can write the formula. So for hydrochloric acid, we will say hydrochloric acid. So we are saying A. For us to answer A, first thing we know, when talk of concentration is equal to C is equal to N over volume. Then this N represents N here represents the moles, and V is volume, and this volume should be decimeter cube. So now what we have been given are centimeter cube. So we need to know that when we talk of convention, there we'll say 1 decimeter cube is equivalent to 1000 centimeter cube. Then here we don't have. Then what we have been given is 300 centimeter cube. So whatever that we are going to do here, when we do our calculation, find that our X, which is volume, is equal to 0.3. decimeter cube. So this is what we have. So where there is volume, we replace this one. Where there is concentration, we replace what this value here. So this value represents what concentration. Yes. So say here we write this one is equal to we are calculating the number of moles, then 0.3, there is 1.0. So when we do the calculation here, we find that the moles of hydrochloric acid N is equal to this and this. We'll get 0.3 moles, 0.3 moles of hydrochloric acid. So this 0.3 moles of hydrochloric acid, these were the total moles of what hydrochloric acid even before it can react with what this impure limestone. So this was what the total moles of hydrochloric acid. So what we do, we are also going to find the moles of this hydrochloric acid that reacted with sodium hydroxide. So finding that, we have this here, we have been given the mass of sodium hydroxide. This is the mass of sodium hydroxide. So we say sodium hydroxide, so its mass is equal to 4.0 gram. Then let's calculate the molar mass, the molar mass of sodium hydroxide. So molar mass of sodium hydroxide, we know. Okay, so we have this molar mass of sodium hydroxide. Molar mass of sodium hydroxide, iodine there is 1 by 1. Then oxygen here is 1 by 16. Then 1 sodium is 1 by 23. So when we add this, we find that here the molar mass is going to be 40 gram per mole, 40 gram per mole. Then having this, we can calculate the moles of this sodium hydroxide. So to calculate the moles of sodium hydroxide, we'll say N is equal to mass over molar mass. Okay, so N is equal to, there we have it's 4.0 gram, then over 40 gram per mole. Okay, this is what we have. So we can cancel this and this will cancel. Then 4 there is 1, 4 there is 10. 10 into that, so our answer mole there is N is equal to 0.1 mole. So this is mole of sodium hydroxide. Okay, mole of sodium hydroxide. So this procedure just there to help us to find the mole of what hydrochloric acid that reacted with this sodium hydroxide. So having this, then here in this information we have been given this equation here. So we have been given this, as you can see, the moles this side is 1 and this side is 1. So whatever that you are going to do, you find that the number of moles of this sodium hydroxide is equal to the number of moles of what hydrochloric acid. So here the even hydrochloric acid is what 0.1. So therefore we are saying that here hydrochloric acid hydrochloric acid. So moles of hydrochloric acid, we are saying that moles of hydrochloric acid is equal to 0.1 mole. Okay, these are mole of hydrochloric acid. So now the question is, let's not forget the question. The question is determine the number of moles of hydrochloric acid that had earlier reacted with calcium carbonate. So the number of moles that reacted earlier with calcium carbonate, so we'll say calcium carbonate, number of moles, so we'll say number of moles. Yes, moles, we know that it's N, that reacted area with we'll just say calcium carbonate like this. So reacted with calcium carbonate, we'll write the first, which is this one, which is 0.3 moles minus 0.1 mole. So the reason why we are subtracting this is because this 0.1 was the one which was in excess in order for this to react with what? Sodium hydroxide. So total number of moles here was 0.3 moles. So in here we are going to subtract 0.1 from 3 moles. So this is the reason why I've written like this. So here the answer will be 0.2 moles. So these are moles that reacted with calcium carbonate. So reacted with calcium carbonate. Okay, so I'll just say calcium carbonate here. Okay, these are the number of moles that reacted with calcium carbonate. Okay, so just having this, which means we are done on question A. B says calculate the percentage purity of calcium carbonate in limestone. So now we need also to follow what we have been given. Here what we have been given, this limestone is what? Impure. As you can see there, it is what? Impure. So this mass that we have been given, it's what? Impure. So what we need to do first is to write down the formula that we use, or that is used when calculating this, when calculating the percentage purity. So the formula here, we say it's percentage purity is equal to pure sample, or pure mass in this, just a pure sample, then over impure sample, then times 100%. So this is the formula. So having this, what we have here, we have this mass, which is the impure one. This is the impure one. Then what we need to do is to calculate the mass of is to find the pure mass, or the theoretical mass. So how are we going to calculate this mass? We know the number of moles that was reacted here. So the number of moles that reacted with calcium carbonate, we've answered it to say it's 0.2. Yes, so the number of moles here, we've said it's 0.2. This is the number of moles of hydrochloric acid. So just allow me to write the equation. So here what we have this equation, then the number of moles that reacted with this calcium carbonate, we have found that it's what, 0.2 moles of what, hydrochloric acid. So these were the moles of hydrochloric acid, moles of hydrochloric acid that reacted with the calcium carbonate. Yes, that reacted with what? Calcium carbonate. So in order for us to answer here, we'll write in form of what? Ratio. So let's say if at all we'll say N, which is representing the number of moles, then here is calcium carbonate like this, then over the coefficient of this, it's 1, there we don't have, then is equal to, here we have this hydrochloric acid, so we say N open bracket hydrochloric acid. So the coefficient here we have what, 2. Okay, so now we write the moles that we have. So for hydrochloric acid we have this, then what we want to find is the moles of what, this calcium carbonate. So we'll say N moles of calcium carbonate like this is equal to, so where there is hydrochloric acid we write what, 0.2, so we say 0.2 and then over what, 2. So here what happens is, once you divide there, what the answer that you get is 0.1 moles. So this 0.1 moles are moles of calcium carbonate. Okay, calcium carbonate. So these are moles of calcium carbonate. So having the moles of calcium carbonate, what you will do again, in order for you to find the mass, you use the formula to say N is equal to, we say it's mass over molar mass. So we have this mole and we have the molar mass of calcium carbonate. So here we are going to make mass subject of the formula, or before that we can just go direct and find the molar mass of calcium carbonate. So for calculate the molar mass of calcium carbonate, let's do it from here. So we'll say calcium carbonate, it's like this, then 3 times 16, this is the mass number of oxygen, 3 by 16, okay, 3 times 16, and then here it's 1 by 12. So these figures you'll find them on the periodic table. Then calcium is 1 by 40. Okay, so we have this. So once you add this, you get 100 grams per mole. So this is what we have. So what we are calculating here is mass. So just get this and replace. So here where there is N, you replace by 0.1 more. So here we'll say 0.1 more. Okay, more is equal to mass. Here it's mass over this one, which is 100 gram per mole. Okay, 100 gram per mole. So here we say 1. So this and this, you say, or you have mass is equal to, when you multiply there, this one will cancel. So we are going to have, so here we have 10.0 gram. So this is what you are going to have once you multiply this and this. You have 10.0 gram, because this you are just multiplying those. So this point will shift, yes. So like that, having this mass, which means you can now calculate the percentage purity, where we even wrote the formula to say percentage purity is equal to pure sample again over impure sample times 100. Then where there is pure sample, you replace by the one that you've calculated, which is 10.0 gram. Then over impure, you have this one in the question, which is 10.2 gram times 100%. So here gram will cancel each other, so this one will divide. Then once you place this on a calculator, just use a calculator to find the percentage here. What does your calculator give you? So here my calculator is giving me 98.0392 somewhere there. So we'll just round off this to 1 decimal point, which is 0.0, so which is also equivalent to the nearest whole number, which will be 98%. So this is the percentage purity of limestone. Thank you very much for following.